Hello learners, today I will study the texture of sedimentary rock. In order to give you an outline what I am going to discuss in this particular session, I will speak about the types of texture. They are based on grain size, the other parameters like graphical representations, the morphology of grains, how the grains are packed, we call it packing, various components of clastic texture, the concept of textural maturity, and texture of non-clastic rocks. And then finally, I will give you a summary of the talk. There are two major texture types in sedimentary rocks. First is clastic texture, other is non-clastic texture, which you also call it crystalline texture. They have different compositions and textures. They are the product of provenance, product of transportation, and various types of depositional environment. We'll discuss more details about the texture in this lecture. What is sedimentary structure? It refers to size, shape, and three-dimensional arrangement of sediment particles. It is determined by density, porosity, and permeability of the rocks. Texture controls the transport of particles from one place to another, the energy required to remove a particular grain size from one point to the other, and it also tells us about the environment prevailing in the basin. The most important part of texture is packing, how the grains are packed. This refers to the distribution and the density of grains in a sedimentary rocks. It is a function of grain size, grain shape, the sorting, and the degree of sediment compaction. Packing is explained by bulk density, porosity, or permeability. These two important components, permeability and porosity, are very significant in understanding the packing of grains. Permeability refers to the passage through which a fluid is transmitted. On the other hand, porosity refers to void between the grains. Depending upon the sedimentation and diagenetic history, packing can be classified into two types. You must remember that diagenesis reduces the porosity and also permeability because of development of new minerals in a particular sort of environment. There are two types: primary packing, where the detrital grains possess their arrangement that existed after they came into rest in the position or after precipitation. On the other hand, the secondary are produced due to alteration in the original arrangements of grain. The secondary process, secondary packing is mostly due to diagenesis and the creation of new grains into the sediments. There are three types of support to the grains. The sedimentary grains, when they are moving into a setup in a depositional basin, they tend to form a rock. Either they are supported by grains, that means one grain come in contact with another grain and then third grain. So all of them are grain supported. All grains are coming in contact with each other. On the other end, there is a matrix supported, where larger grains are supported by smaller grains formed by the breakdown of the other rocks like mica and other chert and etc. A third type is the cement supported, where the grains are supported by secondary material like calcite or iron, ferroviary material. This cement the grains. They call cement supported. Is the component of classic texture is diagrammatically shown here. You can see the grain. You can see the one here, one in the matrix. You can see on the right side there is the matrix. There are larger grains, round one, round grain, and the small fragments of the other material. They tend to sort of hold these bigger grains in a plain place. On the other end, cement supported, where there is another grain is the calcite, other mineral develops, siderite, and other things develop, and they tend to bind these larger rocks because cement supported. And the first one is called grain supported. Each grain is coming in contact with each other, and they produce the pores in between. We call the word a clastic texture. Clastic texture is derived from pre-existing rocks. Texture produced by physical processes is also affected by biochemical processes. It is determined by the grain size, sorting, roundness, packing, textural maturity, the matrix, and the cement. The examples of some sedimentary rocks are with the class showing plastic texture are sandstones, arkoses, and conglomerate. Packing leads to lithification. The grain to grain contact, some grain could be a tangential contact, that grains coming touching each other on a tangential basis, or there could be concavo-convex, grains penetrating one another, or they will be sutured like styrolytic penetration of grains, or they are long straight contact. So obviously the packing will be either loose or will be tight or will be cubic or rhombohedral. This is one example of the imbricate pebble texture. It shows the current direction, and you can see the grains are oriented in particular direction, particular from left to right. This is a packing of cubic and rhombic packing. Cubic packing, you can see you have a large amount of porosity. The grains are touching each other, and then it gives you 48% of porosity. Then, on the other hand, if you have a rhombohedral packing where the grains fit into each other more closely, then you get a low porosity, 26% porosity. Similarly, the grains could be, as I told you just now, that they could be either grain supported or matrix supported. On this side, you can say the grain supported grain, each grain is coming in contact with each other, and they all combine together and retain its shape as in the form of a rock. On the other hand, there is a matrix supported packing. There are large grains here, and is all supported by fine grain material, which are formed by the breakdown of these materials. What's the importance of packing? Importance of packing, that it gives information about the origin of the rock, that is the genesis. It tells the nature of fabric. It also tells about the direction from where the sediment has come. It also tells us about the state of porosity of the rock and permeability. These two properties, proper porosity and permeability, are very significant in geological studies, especially transmission of water or transmission of oil in the petroleum field. In water, it is how the water will move from one point to the other, and how much matter will be found at a particular depth will all depend upon the porosity or permeability of the sedimentary package. The importance of packing, I again repeat here, that they help determine the genesis of rock, as I explained you, The class supported gravels tells you about the stream or a beach. On the other hand, the metric supported packing tells you that must have formed by a mud flow. Similarly, dip of the long axis of the class tells you the direction in which the class have moved, and in other words, it tells you about the paleocurrent direction. It also affects the aggregate, the strength of aggregate. Now, a particular rock may be of particular use because this is very important in engineering properties of rock, where the sedimentary rock is used for construction purposes. So, more strength gives you the strength of the rock tells you which material will be used for what type of studies. Whether they can be used as a roofing material, or they can be used as a flooring material, or they can be used as a pillars. So all these packings will tell you what exactly is needed for a rock to become strong. Now, all these particles which we have just now talked about, they have got three characters. They have a shape. They have a very particular shape. We call it oblate, or you also call it discoidal, or they are called equant, or spherical, or bladed, or prolate. They also have the various degree of roundness. Some are rounded, some rounded, or some are very, very rounded. Because roundness will tell you how much the grain will roll in a particular sedimentary bed from one end to the other under the influence of a particular current. So round grains will roll very fast as compared to angular grains and grains with lower roundness. Same is the case with the sphericity. The spherical grains, the highly spherical grains, will be transported much faster than the less spherical grains. One of the important parameters of grains is sorting. The sedimentary grains, they get sorted in even ways. Most of the grains are of almost similar size and without any material, neither cement or matrix or any other material. So therefore, such type of potatoes are called well sorted. On the other hand, those in which the larger grains are there, and then there are smaller grains that are also there, so we can call it a moderately sorted. Again, there is hardly any cement or hardly any matrix in there. In a poorly sorted part, the large grains are there and the smaller grains surround it, so you can call it sorting poor. All these three things actually tells us how the sediments have been affected by the transporting medium, like water in sea or water in river or water in lake, wherever it is, in where the grains have been tossed from one end to the other end. So if there is a continuous movement of water and the grains have been tossed from one side to the other side in a regular manner, then it will turn into a well sorted sand. If there is less, then you call moderately sorted, and when there is the current action is very low, then you can call it a poorly sorted. There is a particle size of plastic grains. They are the name of the particle. If you see the biggest one, the big one, which we call it boulder. Boulder has got size about more than 256 millimeter, and this is on 5 scale, which I have explained in my earlier lecture what the 5 scale is. It is less than -8. Then there is a cobble. Cobble has got 64 to 256 millimeter size with -6 to -8, 5. Pebble with 4 to 64 millimeter have got -2 to -6, 5. Granules 2 to 4 millimeter, -1 to -25, very coarse sand 1 to 2 millimeter, 0 to 15, medium sand 0.25 to 0.5 millimeter, called 2 to 1.5. Then you have very fine sand 0.6 to 0.625 to 0.125, 4 to 3.5, coarse silt 5, coarse silt 5 to 4.5, medium silt 6 to 5.5, very fine silt 8 to 7.5, and clay is more than 8. Now, all those things, boulder, cobble, with the granule, they are mostly found in the form of a gravel, which are found in a loose pattern. When these gravels get consolidated and get cemented or develop into some matrix, they produce a rock which you call conglomerate, or they can also form a breccia, depending upon the rounding. Breccia is got sub-rounded to angular fragments, where conglomerates are mostly grains are rounded. On the other hand, the sand and different type of sands, up to coarse sand, for very coarse sand to right up to the very fine sand, we produce a rock. They are called sand, and when consolidated, they produce a rock called sandstone, or different type of sandstone like called arkos, you have greyacke, and there are many type of sandstones. And when they become lithified, and then they are also given a name called orthocorzite in some places. Then you have silt, fine silt to very fine silt. We produce a rock called siltstone, and the clays finally form mudstone, shale and mudstone. Now claystone, mudstones they are cemented by different minerals like calcium carbonate or iron ferruginous material, or by different type of volcanic material, or sometimes even hydrothermal materials also make them and produces mudstones. There is a field photograph of sandstone with coarse grained sandstone where iron nodules are knocked off. You can see the small one, the iron nodules have come out of it. On the other side, the field photograph of a sandstone shows medium grain beds. You can say the granularity of the sand is medium grain. Another field photograph showing coarse grained sandstone where clasts are knocked out of it. And field photograph of sandstone showing very coarse grained beds. Upper side you can see very coarse bed, while the medium grade in the lower side. The pen is the writing is coarse grain, and on the lower side is a medium grade. How do we measure the grain size? Grain size actually measured depending upon what we are going to do, what rock you are going to deal with. If it is very big one like conglomerate and other thing, then you can use vernier caliper and just measure it. But if it is fine grain, other methods are used and microscopic methods are used. It tells us about the source rock character. It shows us about the mode of transport. It also tells us about the depositional history. On the other hand, the unconsolidated sediments like sand on the riverbed or on the shallow coast, they are used by other methods like different type of tubes, putting into a grand suspension on the basis of the suspension of time taken by suspended material is used for getting inside. The consolidated sediments on the other hand are represented by histograms and frequency curves. The rock is supposed to be mature or immature on the basis of certain parameters. This is called the textural maturity of sediment. It reflects the relation between the texture of the sediment and the transportation processes. We call it super mature when all the grains are of similar size and there is no small particles in that and no clay particles in that. You call super mature. Mature will have the finer particle and smaller particle together, but the small amount of other finer particle. And immature is that which has got only finer particles and other clay particles and has got no stability. That What controls the texture? Texture and composition of source rocks, nature of weathering agencies, nature and extent of transportation, the depositional process, diagenesis, and tectonic stability of depositional sites. So, texture of non-clastic rock, on the other hand, we are talking of, so far we spoke about the clastic rock. Now we discuss with the texture of non-clastic rock. Non-plastic rocks are formed by chemical processes. They show crystalline texture. Rock is representative rock. The lithographic stone is a very fine-grained carbonate rock, limestone. Most limestones, most dolomites, they are all formed by crystalline texture. And non-crystalline textures, which has got oolite, pisolite, and alga nodular, they say irregular. So, in both cases, matrix or cement as binding agent. Mostly it is cemented. Matrix is very rare in non-plastic rocks, but cement is the most prominent one. Non-plastic texture is formed by precipitated by chemical or biochemical processes, by recrystallization and alteration of pre-existing rocks. They show interlocking mosaics of crystals, for example, limestone and dolomite. In order to summarize, texture refers to the size, shape, and three-dimensional arrangement of grains that make up sediments or the sedimentary rocks. Texture undertakes importance in many of the significant properties such as bulk density, porosity, and permeability. The texture of sedimentary rocks is used to infer the mode and distance of transport, energy condition, and deposition processes. Texture can be clastic or non-clastic depending upon whether composed of grains from pre-existing rocks or the grains develop an interlocking mosaic of crystals from a chemically or biochemically produced fluid. The most useful aspect in grain size distribution is sorting. It reflects the energy condition of the transporting medium from which the sediment was deposited. The degree of rounding of grains gives clues to the amount of time sediment has been in the transportation cycle. Pattern refers to the arrangement, spacing, and density patterns of clastic grains in the rock. It is a function of grain size, sorting, grain shape, and degree of compaction. Matrix is the fine grain ground mass on which grains are embedded or float. Cement is chemically precipitated orthogenic minerals in the porous spaces between the grains. Thank you.